Thank you very much, and good morning, good afternoon, everybody. I will be sharing some different ideas, put some things into the chat as I go. That just makes things all the more interesting for everybody, I think. So if you want to introduce yourself or share anything in the chat, then please go ahead. And what an amazing time we're all in. Who could have anticipated this? And if you're teaching at the moment, my heart goes out to you. I'm teaching at Stanford, and it's so difficult to teach and have kids have the same quality experience online. And I know it's a lot of work to get that to happen. So thank you for joining me. And yes, I can make these slides available for people as a PDF. So up there on the screen, you see some details of our center at Stanford. If you haven't been to UCubed, I encourage you to come. It's lots and lots of free resources for everybody. So what I want to share with you today is how we can give tasks to students that really open up their minds and open them to learning. Before I get to the tasks, and we're going to be looking at some different ideas, K-12, I want to share what I always start presentations with, which is the really important messages to kids about learning and about the brain. We know that so many students think that, when they struggle, they think, oh, I haven't got the right kind of brain, I'm not a maths person, yet their brains are developing and growing all of the time. I wish they all knew what's on the screen in front of you at the moment. Every time we learn, these brain changes are happening. Nobody's born with the pathways that develop. So there are no limits. If anybody doesn't believe this, my book, Limitless Mind, is packed with evidence and examples from teachers about how they took on these ideas. Every time scientists try and find a limit to what somebody can learn, they can't find them. So we need to change ideas around that and structures that actually limit kids. So one of the keys that I share in my book is just the really important times when people are struggling. We know those are the best times for people's brains. If you would like a nice summary of all the evidence on why we want to be struggling and making mistakes, this is on the news section of our website. It's written for students, obviously of a certain age, and just shares all the different evidence that we want kids struggling and making mistakes. So when I teach, I always share with my students, I want you to struggle. I love mistakes. These are the best times for our brain. And I find that message is liberating for students. So we know now at this point in the world that changing people's mindsets is really important. It changes a lot of different things. The evidence is really conclusive. I thought today I would share a little bit on, somebody's asked for the link to that article. I can't share it while I'm presenting, but it's under the news section of UCubed. Just go UCubed and news, you'll find it there. So I thought I'd just share one of the pieces of evidence around mindset today. I'm sure you've seen a lot of different things, and this is some evidence around our health, so very important to all of us. And I find this study really interesting and amazing. Stanford researchers followed over 61,000 people over 21 years. And this is what they found. The people who thought they were doing healthy exercise were actually healthier than the ones who didn't think that, even when the exercise they were doing was exactly the same. So we know now that our minds can really change our physical bodies and our health. And in case you don't think this is important, the negative thinkers were actually 71% more likely to die in the follow-up period. So it's pretty important that we have a growth mindset about ourselves, our health, our learning. And we know that the impact on learning is very strong. This is part of how we know this incredible study, that these are actual voltage maps of brains in the study. They found that when people with a growth mindset made a mistake, their brains were on fire with brain growth. And That is the orange brain on that slide, compared to people with a fixed mindset. So this is really strong evidence that what you believe about yourself will actually change your brain. We know it changes your health, and it will also change your brain. So really important that we think positively about ourselves, about our kids, and it helps us make sense of all the evidence we have that kids with a growth mindset are on that upward trajectory. So the good news is anybody can change their mindset at any time. You may have children with a fixed mindset, you may have students, you yourself may have fixed ideas. It isn't a quick switch, you know, it's a process, but I do find that once people become aware of the science, change starts to take place. And I wanted to share that Carol Dweck, who I'm sure you know is the guru on mindset, who really developed this whole field, has recently changed her mind about mindset. And I was presenting with her recently to a group of Australians. This is me and Carol in that presentation when she shared this. And what she shared that day was she used to believe that everybody had a fixed or a growth mindset, but now she realizes we all have times of fixed mindset thinking. And it's actually really important to identify your triggers. What pushes you into thinking, I can't do something? And she suggests giving a name to your fixed mindset. In fact, that day she shared that she had been presenting to a group of a company when the CEO of the company shared that he was naming his fixed mindset Dwayne. And this is what he said: when we're under pressure, I become Dwayne and I get super critical and bossy. And one of the young women in the company said, yes, and when your Dwayne comes out, my Iana comes rushing out and I become stressed and submissive. So identifying your mindset, identifying what pushes you into thinking I can't do something is the first step in changing those ideas. So I've shared a couple of things already that, you know, when we know about the way the brain works and the power of struggle and, you know, we really take on a growth mindset, people start to interact differently. They go through their lives differently. And there's a lot of evidence of that in my new book. And I really believe if you live just one day with a limitless perspective, you will know it, especially if it's a day when something goes wrong. But for learners, this isn't enough. So this is where we start thinking about how do we really get these ideas to kids? And this is why it's not enough. This is how I like to think about it. A lot of teachers and others have jumped on the mindset bus or bandwagon, and they're sharing with their kids, you know, you've just got to work hard, and that's great. Those are really important messages. But what we find is when those growth mindset messages hit the wall of fixed mathematics, those messages fall flat. And what I mean by fixed maths is any question that has one answer, one method, is very narrow. And so I've shared some of these keys with you. I want to show you what I mean by this as we look at tasks. And I think that there are certain tasks that really change people when we have them engage in these tasks. And we're going to look at a few of them, and we're going to look at what happens when kids get these different ideas. So the first design feature and the only task I ever use with my own students I teach, tasks that can be seen and solved in different ways. Now, of course, any maths question can be seen and solved in different ways, but how do we encourage the seeing and solving in different ways with students? Many of you have probably seen the example I like to share of algebra and how algebra is so much pushing X's around a page for kids, but actually we can make algebra a pattern seeking activity. This one I've used a lot. I won't go into depth on this today, but instead of asking how many are in the 100th case or the nth case, we just make a tiny change and ask kids, how do you see the shape growing? And what happens when you make that tiny change is kids have all sorts of different ideas. They're really engaged. They share the different visuals with each other. As you can see from this overview slide, all of these different ways that kids see the growth can be described algebraically. And that would give us a room full of different algebraic expressions, all of them equivalent to each other. So if you are teaching algebra, if you are teaching pre-algebra, I really recommend, we have a section of our website with 4 weeks of visual, creative algebra tasks, all free, gives you lots and lots of great resources if you're doing any algebraic work with kids. But the good news is we can really take any maths question and open it up. I was watching a classroom recently. It was a first grade classroom where the teacher had the kids gathered around the board and she said to them, "My number is 20. How could I get there?" And the kids were so excited. They were all sharing their different ideas. And we can do this with any mathematics. Instead of giving kids these narrow questions with one answer, why don't we just give them the answer and ask them, where do you think this answer comes from? You could take any content at any level and ask these kind of questions. Instead of asking kids, as textbooks do, what's the area of an 8x3 rectangle? Why don't we just ask them, I've got a rectangle of an area of 24. What rectangles do you think it could be? Soon as you make that change, kids are thinking of all the different ways they can think. They're thinking visually, they're justifying, all sorts of important things happen. One of my favorite questions when I'm teaching kids and somebody shares a way of thinking is to ask the class, does anybody have a different way? When you get different ways of thinking out, that's fantastic. That's when you can have kids start having a debate with each other, asking them if they understand each other's different ways of seeing. So this is one of my most important ways I teach, is by valuing this difference. And that valuing of difference allows mindset messages to really take hold. So another feature I wanted to share with you in my teaching, and we're going to watch a video that I hope will play okay through my Wi-Fi, is teaching kids that mathematics is all about pattern seeking. I love to tell kids, you're a pattern finder. This is really the whole job of maths, is finding patterns. And I don't just mean like algebraic patterns. When kids see that every time I multiply a number by 10, I add a 0, that's a pattern. So I love kids to see the whole of mathematics as a pattern seeking venture. So I thought I'd share with you some examples of this that come from our UCube summer camps. On the front page of our website is a video of a camp we ran in 2015, where we gave kids these messages. We celebrated open mathematics, and the kids increased their achievement by the equivalent of 2.8 years in 18 days. This camp was so successful, and as I said, you can watch a video. It's on the front page of UCubed. In 2019, we ran a different camp, and this time we decided to have the camp just be for girls. So you may be wondering, why would you restrict a camp to girls? And this is why. When we ran the first camp, it was super successful and we loved it. But we did notice that when mathematical conversations were going on across a whole class, it was often the boys who were talking and the girls were very quiet. So we thought, well, what would happen if the boys weren't there? Would the girls then be the ones who would be having the discussions? So what happened was, it really kind of shocked me actually. When we started our camp with the girls, they were so quiet, so kind of locked up really, that they really were not willing to share things. But we kept going, we kept sharing mindset messages and open mathematics, and things changed. So I'm going to show you what happened. And this camp for girls, they were middle school girls, so really that age when kids are very self-conscious. So in our camps, we always work to change maths for kids, from that list on the left to the list on the right. And let's have a look at what happened when we tried this with girls. Oh, so a couple of tasks we used. I love Pascal's triangle, and I love to just give it to kids and say, what patterns can you find in Pascal's triangle? This actually links to college level mathematics. And I say to kids, there are probably patterns in this triangle nobody's ever found yet. It's such a complex, an amazing triangle. So we did work on with Pascal, you'll see it in the video. And then one of my favorite problems, another lovely problem that extends really from 3rd grade to college, is a problem that is called the Collatz conjecture. Mathematicians have called it a conjecture for a long time because nobody has ever solved it. It is an unsolved problem in the history of mathematics, although they're getting closer to solving it, which is interesting. But it's a number pattern, and you see on the screen the sort of rules of the pattern. And so we give the kids this pattern, and then we say, what do you think is going to happen? And we shared with them, well, you're going to see on the video what happened. So the Collatz conjecture, as I said, it's an unsolved problem in the history of mathematics. So of course, we share it on our website for 3rd graders and up. It's also known by mathematicians, I love this, as the hailstone problem. They call it the hailstone problem because the numbers behave like hailstones. They sort of go up and come back down again. Mathematicians speak about it in these very, fixed ways as they like to. Mathematics may not be ready for such problems. This is an extraordinarily difficult problem, completely out of the reach of present day mathematics. So as I said, of course, we give it to 3rd graders and up, and they have a fantastic time with it. And what you're seeing here is some little kids working on the pattern, some older middle schoolers plotting all the stopping times. But let's have a look at what happens with these girls. So as I said, I hope the video plays okay. And I have a question for you. I'd like you to share in the chat box. You can share it while you're watching the video, or we'll pause a bit after the video. What happened to these girls? As I mentioned, they started off really kind of locked up. They didn't want to share things with us. They were very, very afraid, it seemed. So what changed? Let's have a look.
I've been liking math since kindergarten, but it was a little struggle for me because I didn't speak English. We had this multiplication test, and then you had to finish in 2 minutes, and I would only get all the way to my 4. In school, there's all these grade tests and gaps in between learning, and sometimes you can't really get everything into your head if it's going at a fast speed. When I see quizzes personally, it makes me scared. It makes me nervous. If you're good at it, you'll react in a happy way. And if you're not so good, you'll just really sad and confused. Some kids are falling behind. They're considered dumb kids. That's really not it. It's just they need more time. In math class, I was really shy because I was afraid that I would get the answer wrong, and then people would be commenting on it.
How would I show this as 12 and 6? Anyone? Everyone's very quiet. You can talk to each other about what you think. I want to share a famous triangle. It's called Pascal's triangle.
At school, teachers say, no, you can't have fun doing math because math's not fun. But here, they make it lots of fun.
So then we're connecting visuals and numbers in our brains.
I like to draw, and when I draw things out, it helps me learn math better and helps me with the equations and stuff.
Did somebody do it a different way, or can you even see another way to do it now?
In my school, they only show us one way, and if you don't do it that way, we get it wrong. When we came to the summer camp, there's many different ways, and everyone shares their thinking. This one, there's a pattern right here. I noticed something, and I put my whole face on the paper. And then we were raising our heads. We got a pattern, we got a pattern. put our heads together like that. We were like,
I'm going to tell you a story about a maths problem. A really important mathematician, who's called Fermat, said there is no set of 3 numbers that would make this statement true. Andrew Wiles had a proof of this, and there was a mistake in his proof. The mistake he made in his proof started a whole new branch of mathematics. Another thing we wanted to share about the value of mistakes.
in camp, our teachers are like, your brain grows from when you make mistakes. It's better to have all that encouragement so you can like feel reassured that even if you do make a mistake, you're not going to be like shamed for it.
All right, you ready for something cool? So we're gonna pick a whole number. If the number is even, divide it by 2. If it's odd, times 3 and add 1. Pick some numbers with your partner, talk about them, work on them.
When we work in groups, if somebody has an idea, like we can build on that idea and see where it'll take us. We have a better chance of learning something new when we're together.
225. Then divide that. 40 goes to 20, 20 goes to 10, 10 goes to 5.
I wanted to tell you something about the problem you've been working on. It is a problem that is unsolved in the history of mathematics. It's known as the Collat's conjecture. In the field of mathematics, when people have an idea, they call it a conjecture, but it's also called the hailstone problem. The numbers behave like hailstones because they go up and then they come back down again. Do you want to do more Collat's conjecture till the end of class today, or would you like a different number pattern to look at? This? Okay, keep going.
I used to have this perspective of math, like that I need to do it quick, I need to be good. And if I'm not quick, I'm not good.
It's more relaxed here. It made me see less of the answer and more of connections.
What if you reflect the same thing from the other way but negatives?
Oh my gosh, I've never heard such an interesting question.
Yay, she's in the 92. Yes, yes.
You finished a million. Wow.
A million went to 1. That is great.
Now up to a trillion.
Okay, a trillion. Here we go. Wow. 91's going on for pages.
If you reach 91 again, then you know that that's the answer.
While we were working on this maths problem, some of you took us into the realms of college maths.
I actually feel better of myself because now here I was like, wait, you don't need to be smart, you just need to try hard.
To ask questions, to speak up, like share my answers, even though it's wrong, helped me gain more confidence in math.
When I came here, I'm like, now, wow, I really love math now. I really want to go back to school now and like show, like, I can make mistakes, but I can still succeed in life.
As you can see, some pretty important changes for the girls, and I'm loving what I'm reading in the chat room. Lots of people are talking about what they saw as different for the girls. I'm going to give you a moment just to share now, if you would like to share some more about that. People are saying they're able to explore. Yeah, I like the point that some people are making is that there was no test. Right, we did have one test at the end, but we really were not oriented towards grades or towards tests. And this is what I like to call mathematical freedom, where kids, anybody, adults, able to explore without the pressure of feeling that what they're doing is being graded or that there's a test at the end. Sadly, I teach undergrads at Stanford, and sadly, many of them come to my class having never experienced what I would call mathematical freedom, as just being able to think and be creative. And it's incredible when they get that opportunity, but it's very sad the way maths has become this performance subject in our schools. And yeah, we try and work against that. But we do know, what's great is we do know that there are teachers who use these ideas in their classes, even when they're in the system of grading and testing and everything their school boards and others want them to do. And still they have amazing changes in kids. A lot of those changes are written in my Limitless Mind book. So I hope you like that video. There's more to see, but I was going to say that I felt there were 2 changes that happened for the kids, 2 really big changes. One, those mindset messages and messages of struggle caused them to start believing in themselves. But then the second really important change, and I do think these two things go together, is they saw maths as a subject that could be seen and solved in different ways. That content piece is so important. Somebody in the chat mentioned that their socio-emotional learning had changed, and I agree with that. And I also really think that to have those great changes in kids, we need to change content. It's not enough just to be giving different messages. So in our first camp, as I mentioned, in our mixed camp, we interviewed some of the kids afterwards. I wanted you to hear from Michael. He was one of the highest achieving students in our whole camp. And the groups were heterogeneously mixed, of course. And some people worry about high achievers. When a class is very mixed, we had kids with IEPs who were performing at second grade level, and we had high kids, and they were all together in the same classes. And some people worry about the high achievers. Maybe they can't, achieve as well. So let's listen to Michael reflect on his time in our camp and his time in tracked classes when he was in a high achieving group.
Yes, I have. I've always been pretty good at math. I've always been able to understand it pretty well. So it's like in school, I was always like, I would always finish around first or somewhere up there, and it was like I'd sit there and I'd be like, "You done yet? Hey, how you doing? You good?" And I sit there. It's like, but now I would always think it's like, how do you not understand this? And now I came here. It's like, oh, I should really let them think about it more, and I should think about it harder myself, because not only, even if I know the answer, just thinking about it harder will make me understand it more.
So he's reflecting there on a process we used in our teaching, which is that if anybody finished first, instead of giving them other work, we would say to them, can you think about it differently? Can you solve the question in a different way? So in his regular maths class, because they worked on narrow maths, you could hear him saying, I'd sit there and think, why aren't you finished yet? But when you open up the maths and celebrate depth and going slowly, he and others were able to take on a different approach. So you might be thinking, well, these kids came to Stanford, of course they did well, blah, blah, blah. But so last year, there were 20 of these U-Cubed maths camps ran all over the country, regular teachers who'd come to our workshops at Stanford and really wanted to do this for their kids in their region. And we have some preliminary results from these camps, which also show massive learning gains for kids in a really short time. Definitely noticeable on this graph that the longer they were in the summer camp, the greater the boost for their learning. So if they had 30 hours in the camp, you can see that their gain was up to 30 months in their learning. So we know that this is a really important change for kids. If you want to get these ideas to your kids, I'm sure you give them the ideas, but if you would like another way of getting the ideas to them or to your parents, I have a free online class. It's called How to Learn Maths. It's like 15-minute sessions, about 6 of them. That graph is showing the COVID numbers of the kids taking it since COVID, but there's actually been about 500,000 people have taken this course. Some districts give the course to parents so that the parents get an understanding of the changes that we want to make. So I've taught this class with my undergrads. It's kind of fun and really works with any age group. I've had kindergarten teachers use it with the kids, so they watch it together and then talk about the ideas in it. So I want to spend the last half of our time together today talking about our new initiative at UCubed and why it's so important for every teacher, K-12. I'm going to talk a bit about some of the reasons we need to change high school, but I'm going to share some resources for little kids. So this is our new initiative, and it's really about bringing this very important, very exciting new field that's called data science into mathematics to modernize and enrich our maths courses. So why are we focusing on data science? You probably realize that we're in a really special time at the moment in lots of ways, but one of the ways is the world is filled with data. The COVID crisis has really highlighted this. Look at some of these statistics. We, I believe, have a moral imperative to teach our kids how to make sense of data so that they can separate right from wrong. They can separate when they're being misled and when they're not. It's also going to be extremely helpful for their lives. 7 of the 10 fastest growing jobs have data science in the center of them. And almost every job now, whatever field you're in, every employer wants their employees to be able to make sense of data. So we have lots of resources on UCubed. This is one of them. It's a picture book. We were thinking teachers could use the images as posters if they were actually in the classroom, but kids can color it in. They can write reflections about it. One of the ways of our kids becoming data literate that's so important is learning that they're giving away their data all the time, every time they use one of these, every time they play an online game. So this data literacy is very important for kids. Data science is different from stats. You may be thinking, I learned stats in school, or my school has a stats course. And these are the ways it's different. Stats tends to be taught as a set of methods quickly, like a lot of maths, but data science really starts with rich data sets. And it's really great if teachers bring in their own local data set so kids can ask questions of that data. They can feel, I'm asking questions that could help my community. It could be data from New York or wherever you live. And then different kids ask different questions. I was talking to a data scientist the other day, and she said, in my classes, every person asks a different question of the data. So much more flexible. It is a naturally cross-curricular subject. And if you're a teacher of multiple subjects, fantastic. You can bring data in and be checking off your science, your maths, your communication. There's so much in data. And one of the things I love about this new field that's emerging is that it's the field of data science is really being communicated as a field that anybody can work in. Unlike mathematics, which has been communicated over the years as something that only some people can work in, data science, what you'll read all the time is anybody can become a data scientist. You take the courses. So I work with a group at Stanford called the Women in Data Science Movement. One of their goals, we know at the moment in these early years of data science that there's a lot of women in data science, but we also know that when a field becomes very popular, particularly when it's high tech, sometimes all the men jump into it. So they're really keeping an eye on how do we keep data science a gender equitable field. Obviously, there are many equity implications of this that I'll get to in a minute. But they've made this nice video. It's on our website if you want it, for teenagers to learn about data science and all the diverse ways we can think about it. So let's have a look at this video.
Data science can be found everywhere, shaking up almost every aspect of our daily lives. But most people really hadn't heard of it until about 10 years ago. It's one of the fastest growing fields today, so there's a ton of opportunities for everyone to be involved. Anyways, what is data science? In a nutshell, data science combines data collection from sources like social media and satellite images, faster and cheaper computer systems, foundational math and statistics, and data visualization. Together, these things give us helpful information for making decisions and tools to make our world a better place. Now, imagine you're relaxing at home and you've just finished rewatching the series finale of your favorite show. Whatever will you watch now that it's over? The fact that your streaming service keeps suggesting teen dramas isn't a coincidence. As you can probably imagine, data science can be used to solve other bigger real-world problems. It's a field that requires constant collaboration amongst people with a variety of backgrounds and expertise. Diversity and teamwork are essential, particularly when data is used to help tackle big challenges like healthcare or food or energy supplies. Having a broad set of perspectives helps us avoid bias and other unintended consequences. For example, if a hospital doctor wanted to understand the condition of a patient and the associated risks better, they could analyze data from other patients with related symptoms. In collaboration with medical experts and software engineers, a data scientist can write the algorithms and software to make this analysis fast and more accurate for very large databases, thus improving diagnoses and treatments. So what does this have to do with you? Well, no matter what passions you develop, chances are that you'll be working with data, since it's nearly everywhere and in almost every field. We'll let the data scientists themselves show you a typical day in their life at work.
Growing up, I always thought that I would work at a big company as a computer engineer, as a software engineer. But after graduating from college, I realized I could use my technical skills, my data analysis skills to really serve my country and to serve the community around me. I've gotten to work at a lot of cool places as a result, including at the FBI and at the White House.
I lead a team of data scientists and user researchers to better inform how we make the product much more fun and connections much more meaningful for users throughout Spotify for both music and podcast.
I am a research software engineer building machine learning solutions for wildlife conservation. So basically helping wildlife experts comb through these massive piles of data that they've collected on whatever kind of wildlife they study.
I'm a PhD student at Stanford studying computational and mathematical engineering, and my research is on using satellite images and machine learning to map our agricultural systems.
Yeah, I love Nan just texted so many cool jobs. I agree, data science is a really exciting field. And I want to share a bit about how the equity implications of data science pathways. You'll probably agree with me that for generations, there's really been one main pathway that's dominated college admissions, which has been the pathway to calculus. Yet calculus is a very inequitable, let me just go back to that slide, a very inequitable pathway. It is the only AP course out of 38 APs where you, in many districts, you need to be advanced in middle school to get there. So what that has meant is that that calculus course sits on top of a whole system of tracking, of only allowing some kids to go in that pathway. In many districts, that decision is made in 6th grade, which is terrible that we're deciding in 6th grade whether kids can get to calculus or not. And from there to many top colleges, that's how important that decision is. So many, many things to change in that, more on that on our website. But the other thing we have to think about is the high school sequence of algebra geometry was actually created in the 1800s. This just blows my mind and has never changed since then. Yet the maths of the world has changed dramatically. So we have a new paper out that we're just about to put on our website. It's just being published, that is showing that narrow mathematics really has some negative consequences. We studied a district that was really focused on equitable outcomes. And what we found was, even with all the equity messages the teachers gave, because the maths was so narrow, it led to the kids seeing each other in narrow ways. You know, there's somebody who's fast, somebody slow, somebody who needs help or doesn't need help. So anyway, we're really trying to change the Common Core standards, particularly in high school, We can't just leave it to teachers to try and take this massive, narrow content and make it beautiful. But I decided to get involved in this movement when I received a phone call from somebody not in my usual realm of people, not in maths, not in education. And his name is SteveLevitt. SteveLevitt became very famous for writing Freakonomics. He's a professor of economics at the University of Chicago. And he called me and said, will you please help me try and change high school math? And I said, yes. Oh, the Zoom is lagging. Let's hope it picks up. It's difficult. So he put together this advocacy group, and lots of people on there I don't normally hang out with. Nate Silver, I'm sure, is very busy at the moment. But anyway, lots of interesting people supporting that. But here's the thing, that section of courses of algebra and geometry is taught in schools to prepare kids for calculus. But if you look at the data, for example, in California, only 3% of kids go to a calculus course in high school. So this really raises the question, if algebra and geometry is taught as the way into calculus, but most kids don't go to calculus, are we teaching the right mathematics? The Freakonomics people put out a survey on their website and asked people, what maths do you use in your daily lives? And you see on this graph, the two most common responses, the people saying I use this daily or never. And as you can probably see from this graph, a lot of people not thinking they use the maths they learned in high school, but definitely aware of all of the data work. The Freakonomics people are a bit worried that because people who go to their website are mainly men. So I repeated the survey with a group of education leaders and got exactly the same data. You can see both data sets there, pretty much exactly the same. One was mainly men, one was mainly women. It really didn't make any difference. So I should point out, we're not trying to eliminate calculus. Calculus can be a beautiful subject, as Steve Strogatz shares. But we are pointing out that we should be giving kids different options. Mathematics is a very broad field. Why do we only focus on one area, this very algebraic path to calculus, when we could be focusing on others? And what would happen if we did that? So we're at a very exciting time now, and I want to share some great news that just happened in the past week. In February, I did not know at that point how the world was going to change so dramatically. None of us did. But in February, I said to the Freakonomics group, look, if we're going to change high school maths, we really need to bring mathematicians to the table and teachers. So I decided to invite to Stanford open-minded mathematicians. Steve Strogatz flew over. So did Conrad Wolfram, came over from England. Talithia Williams, but then other people wanted to come. So we had data scientists, we had all sorts of people. Stanford made a press release of the event, and I'm going to share this video of the press release. Yes, I definitely had as a goal for this meeting that it would be at least 50% women, which you probably noticed, and is very important.
We know that the mathematics curriculum that's currently in schools, the maths that students are learning, is really outdated. The world has changed dramatically in recent years, yet our maths curriculum has stayed the same. And in fact, the sequence of high school courses that are in the US, algebra, geometry, was actually created in the 1800s, which is kind of mind-blowing. So we really urgently need to teach kids the maths they're actually going to use in their lives and work and courses.
I believe data science really opens up, both within math classes, but more broadly within education, ways for children to become the discoverers of knowledge as opposed to the recipients of the brilliance of past generations. So at a very practical level, data science is useful because data science is increasingly becoming part of what you do.
We really need to get mathematicians at the table. We're going to change high school maths. So it started off with inviting about 10 mathematicians to come today at Stanford. We ended up having data scientists. There are high school teachers and policymakers are here. People from the universities are here. So we've really brought together those people that we think can make this movement happen.
This is a rare opportunity to gather with experts, other educators, researchers to discuss what is it going to really take to make data science education accessible and valuable for students.
It's a very exciting group that's been put together, and I think it shows tremendous promise for being able to actually spearhead a change. This change will happen. I think the opportunity is to make it happen in the best way possible, enfranchising the largest number of people as we go.
I believe that all of us need to know how to look at data, how to understand data, and to have the expertise to work in the modern economy. So much of every person's job in the future is going to involve some aspect of data, as we've seen data explode in terms of how it's being collected and how it's being used. I really think this is such an incredible opportunity to bring people together to make this change in the education system.
This really seems to have the potential to change the maths in school, change it from a very procedural, meaningless subject for most kids into something that they can see is useful in the world and feel empowered to use that mathematics in the world.
So that's the Stanford press release. You can find that on our website. Some other exciting things to see that are happening. This is a list put together by the Association of Statistics about all the courses in college that require either stats or data science to be taken, many more actually than calculus, although there's a lot of overlap as well. And then this is what I wanted to share with you. This happened a week, maybe 2 weeks ago. The University of California sent an email to 20,000 high schools across California telling them that they have now revised the courses that they require for coming into the UC system to open it up and recognize an introduction to data science as an alternative to Algebra 2. So they are now envisaging a whole different pathway that kids can take. Maybe kids, instead of Algebra 2, take Intro to Data Science and then they go to AP Stats, or maybe there's other pathways. But you can find more of that on their website. Lots of press, very, very interested in this. SteveLevitt and I wrote an op-ed in October saying, you know, we need to make this change, which actually was republished all across the country. Lots of controversial, you know, some of the articles are trying to get people's attention. Is it time to kill calculus? This Friday, I have a photographer coming from the Wall Street Journal to do a press shoot, a photography shoot in my backyard, because the Wall Street Journal is launching a big article next week about this really, what's going on and how important this is. So in other news, I am one of 5 people that's rewriting the maths framework for the state of California. We're in the final stages of that work. When that framework comes out, data science is going to be highlighted all through the grades. And I'm very excited because one of the messages we're giving is kids can take data science instead of Algebra 2. And this course can be open to everybody. Nobody needs to be advanced in middle school. You don't need to have done well in algebra or geometry. It's really not relevant. Everybody can come into this course. We see this as blowing up the inequities in STEM. Many more kids will take a data science course. We're working with a teacher in San Diego who put together her own course last year, a high school teacher. She taught it to 11 kids. This year, she has 100 kids taking it. This is what's going to happen when kids realize that they can take data science. So it's very exciting. On our website, a couple of weeks ago, we shared this that I want to show you. This is a K-12 initiative. We want our kids being able to understand data. And we all know about a number talk where you show numbers to kids, a number problem, and kids share their ideas. what we're saying is this could be a data talk, show kids an interesting data visualization, and just ask them, what are you curious about? What do you notice? We've worked hard to have some data talks that are appropriate for kindergartners. This is one of them, very topical at the moment with COVID. It's data on hand washing, but we have made some data talks specifically for the younger grades. This is actually, we've had over 40,000 downloads of these data talks in 2 weeks. And this is our most downloaded, actually, which is interesting to me. It was really designed for the younger kids. It tells me again how the elementary teachers are open to new ideas and are jumping in and grabbing these resources, which I love. This is one with a slightly higher maths content with percentages in that I really like. So this is one of the things about data science. Data visualizations are really creative. They're not just graphs and pie charts. People are now using all sorts of different ways of visualizing data. And yes, I can share a PowerPoint of these slides with the organizers. Thank you. Nicole has just put in a link to these data talks on our website. This is one I like too. So we were thinking, well, percentages comes in actually around 5th and 6th grade in the Common Core standards. So maybe, you know, if they're percentage data talks, they're going to be more popular with older teachers, kids. But I saw this on Twitter just the other day. This was a 4th grade teacher who shared her 4th graders noticing and wonderings from this Batman. I love, if you look, this is sharing how people were introduced to Batman. I love that these 4th graders said, why did only 15% find out through a movie when that should have been the top thing? So obviously they don't know about Batman comics or any of the, all the different ways people have learned about Batman over the years. But so anyway, some of them have higher degrees of like mathematical literacy, like this one. This is a cool one on our website because you can toggle between 1966 and 2016 to see the changes in the impact of education on your earnings, kind of an important message. So in other things, at UCubed, we're doing something we've never done before, which is we're making a high school course, full 1-year course. We're partnered with Google. It's called our UCubed Adaptable Curriculum, which is why we have a yak there. And it's adaptable in the sense we're encouraging teachers to bring in local data sets. It's all free curriculum, free Google tools. Kids are going to learn all sorts of cool things with here. So lots of resources on UCubed. I have a new online class introducing teachers to these new ideas. I made it in my top room this summer because of COVID and managed to get it out in August. So we got about 30,000 teachers taking it in August, which was great. But also we have these units of work, as you see here, 5 units that are really for lots of age kids, maybe from grade 6 upwards, learning to make sense of data. I saw a teacher on here wrote that their kids love the data is everywhere. And then somebody just asked what's for high school. This is for high school, the 1-year course that we're developing now. If you would, this is the online class. It has little animated movies. You can take it free. You can have your kids watch little movies about, that's my dog Alfie, measures of center and spread. These are people's submissions at the end of the course. I asked them, what did you learn from the course? And there's some of their submissions. So these are the resources we have at the moment. The picture book is really for lots of age kids. You can just share it with kids online. And of course, the data science, data talks are a perfect online lesson because they are all online. And I use them in my own teaching quite a bit. So call to action, if you are anybody who can influence high schools, just getting one teacher to say, I'm going to offer a data science course at my high school will cause this movement to flourish. As I mentioned, we're working with teachers who just offered a course for the first time last year, and now they have hundreds of kids taking it. So that link, that tinyurl.com, will give you a way to be on our database if you would like to be updated with things that we are writing and producing. So if you just go there, tinyurl.com/DSPres details, I can send you we can send you details of the high school curriculum. We can send you the different things that we're getting up on our website. So just another couple of things before we go. We are launching for the first time ever grade focused PD. If you're somebody who's come to our UCubed workshops, we're now bringing those UCubed workshops online, and the first one is in December. But if you're interested in coming to a workshop where we spend a few hours together really looking at great content, there's K2 is first, and then the other grades are coming next year. And then I guess my final message is to take care of yourself. It's such a crazy time. There has never been a time probably that we more need to have a growth mindset and embrace struggle. We're all probably struggling right now in lots of ways, in adapting, making everything online. So that growth mindset is really important for you as well as for your kids. So those were all the messages and resources I was going to share. I'll hang around. I mentioned that I'm on the group Rewriting the Maths Framework for California. Our full day meeting starts at 9. So that's in 4 minutes, but I'm going to hang around for 4 minutes. If anybody has any questions in the chat, or all of this is on UCubed. There's actually 2 places to go on UCubed. Oh, somebody wants the tiny URL. Let me put that back.
My apologies.
Oh,
I couldn't hear what you said.
it's my watch. Be quiet.
Joe, there's a question.
Oh, yeah.
Was if there was UCubed resources that are student-faced, are they available in Spanish?
You know what I would love to share with you? Just stay there.
There, she says.
Okay, I'm back. I just wanted to share this with you because it just came out. This is my mathematical mindset book in Spanish. So I'm excited that this is out. We have a lot of our UCubed materials in Spanish, and anybody who has the ability to translate anything. Oh, can you see it? How do I get it in my, there it is.
There we go.
Anybody who has the ability to translate anything and would like to get in touch with us, and we are very happy to do that. We're a very small team, so our ability to have things in other languages is, depends on help. We have our entire UCubed website is available in Portuguese. You can just click a button at the top because somebody in Portugal did that. Not in Portugal, sorry, somebody in Brazil did that. So yeah. Any other questions? Or?
Yeah, there was a lot of interest in when it's all clear with COVID to bring one of your summer camps to New York.
Yeah.
AMTNYS will be glad to work with you to help that happen. There will be a lot of volunteers here to help that happen.
That'd be great.
People, Nan Gazowski, actually run one similar to yours. And I know there's no time, but I would love for her to share that too. Thank you for coming so much. If you missed anything, Joe graciously agreed to show this recording for a limited time on our website, if that's still okay with you, Joe.
Yeah, that's great. Mm-hmm.
All right. Well, thank you again so much. I know you're very busy, but it was great to hear from you.
Yeah, it's really great to see everybody. Thank you, everybody, for coming and sharing the revolution.